Hello everyone. My name is Dalia. I work as a community manager here at Kong. I would like to welcome all of you. I'm so happy you're joining us. Today we have a very special presentation for you, long awaited. What's new in Kong Gateway 3.0? I know a lot of you have been asking for a long time when we're going to have a user call about that. So I'm very, very happy to have Michael here today, who is going to walk us through what is new in Kong Gateway 3.0. So you will see a Q&A function on the bottom. Please ask all of your questions there, and we'll take them after Michael is finished with his presentation. And yeah, Michael, please take it away from here.
Thank you very much, Dalia. Good morning, afternoon, and or evening, wherever you're joining us from. You might notice that this says Kong Summit 2022. This is a presentation that I gave alongside Guanlan Dai, who's one of our engineering directors at Kong Summit in person at the Palace Hotel in San Francisco. I wanted to make sure that you got the same experience that the people in the room got. So we're going to be using exactly the same slide deck, exactly the same demos, and hopefully you will have a couple of questions afterwards. So I'm Michael. I'm the one on the right. Guanlan unfortunately cannot be here today, but a lot of the content in this slide deck comes from the work that he and his team have been working on towards Kong Gateway 3.0. There's a ton of material to cover today, so we're going to split this session in two. The first part is where we'll run through all the flagship features that we shipped in Kong Gateway 3.0 and any live demos. And then I'll take you on a bit of an architecture deep dive. Now, Kong Gateway 3.0 is our biggest release yet. There are a ton of features in there to make your life easier. And I wanted to take this opportunity to call out a few of them. Really the ones that stand out for me as a user of Kong Gateway myself. Now, we won't have time to go through all of these today. But you can find more information about all of them at docs.konghq.com. Luckily for you, we do have time to dive into some of them. We'll be covering secrets management, a shiny new Kong Manager interface, built-in OpenTelemetry support, and a new router implementation, which is not only more powerful and more performant, but it's also written in Rust, which gains us some internet points. Speaking of the router, that's where we're going to start. So let's dive in. I'd say that the new router is the most crucial feature that we introduced in 3.0. I guess the first question is, well, what is it? Why do we need it? Like, didn't we have a router that worked just fine? And the reason we needed a new router is that as Kong is deployed in companies that scale faster and faster and faster, the scale at which Kong has to operate gets bigger and bigger. Some of our larger customers have over 10,000 routes configured, and that causes issues when you're changing Kong's routing configuration in production. So to solve this, we've built a new router from the ground up to handle the challenges that we've been presented with. Our previous router was highly optimized for runtime, which means that once it had been rebuilt, once it had the mapping of routes to upstreams, it was very, very, very fast. But we made an assumption when we built Kong's router initially, where we thought people would create their routes and then that would be it. And they'd change infrequently, kind of every couple of days, maybe once a week. But that's actually not what ended up happening. A lot of customers are changing routes dynamically, like on demand in response to other events. With the old router, imagine that you've got more than 10,000 routes and you change one, you've got to wait for the whole routing table to be rebuilt. But with the new router that ships in 3.0, it becomes feasible to only incrementally rebuild the routing table, so only update the routes that changed. Our design goals were to have comparable performance. So we wanted better rebuild time, but comparable runtime performance. And we also wanted to start thinking about the future. How can people express more complex routing needs? How can we have a unified implementation for our Lua-based control plane for Coco, which is our next generation Go-based control plane? I'll talk a little bit more about that later. And Kong Manager, which is a web UI. I mentioned that we started to think about expressing these new routing rules. On the left, you can see the old style, which still works, which is still the default in Kong Gateway 3.0. But you can also opt for this new DSL-based approach. I like the DSL-based approach because it's very explicit. It means you don't have to understand that on the left when it says X my header through bar, that's evaluated as an OR. And then when you specify multiple headers, X another header and X my header, that's an AND. Like, that's tribal knowledge. That's just how Kong Gateway works. But if you take a look at the bottom on the right, you can see the explicit X another header equals blah, and X my header is through or bar. It just makes the routing rules very, very explicit. The way that this router works is we build up two runtime indices. One is a hash table, and we're working on building a radix tree approach as well. And you can see that if we do a get for /login, it actually matches two routes. Route 2, which is the exact match, http.path equals login, and route 1, which is any path that starts with a /. That's what that little caret and then equals means. It's a prefix operator, so it says any path that begins with this. The router will evaluate route 2 as the strongest match and route to that upstream. Business benefits for the new router: reduced router rebuild time. That's key. This is the issue that customers have been hitting with lots and lots of routes. So we wanted to optimize for that. We're also seeing increased runtime performance when routing requests for common deployment sizes. With 10,000 routes, we actually reduced P99 latency from 1.5 seconds down to 0.1 seconds. That means that 99% of requests are completing almost 10 times faster during configuration changes on large deployments. And we can express those complex routing needs in a single route rather than having multiple, which means it's faster again. If we can express them as a single route, that's just one route to analyze and process rather than having 3, 4, 5 routes to do the same thing. We mentioned the single route to use it everywhere. This is a great proof of concept. This is building up an AST. So this is how the router actually works internally. But you can change this. So we say the protocol is HTTP, or actually let's put a new one in. The path starts with /foo, and the headers start with hello, and the headers end with world, and it's a HTTP or HTTPS request. So this request will match it. Any request where the xfoo header starts with hello and ends with world on both HTTP and HTTPS requests. I've done a lot of talking, so I'm actually going to show you this. I have a Kong gateway running. What I'm going to do is just create a service and create a route. And you may have noticed that this is not something that you're used to seeing, this expression. This replaces methods and paths and everything else when you're creating a route. And 201 created, we can see that Kong Gateway accepted this. To try this out, you can set router flavor to expressions. in your cong.conf file. If I make a request, we can see that this works because it starts with hello and ends with world, and that matches the expression that I configured. So starts with hello, ends with world. This also works, even though it's got 1, 2, 3, 4, 5, 6 in the middle. It's because it starts with hello and ends with world. But if we drop that D, it no longer ends with world, and that returns a 404 from the router. That is a super quick demo of how the new router works and how you can configure it. Performance is super important. It's why we rebuilt the router, and that's why I'm excited to introduce you to OpenTelemetry, which is a brand new plugin in Kong Gateway 3.0. OpenTelemetry, or OTel, is a collection of tools, APIs, and SDKs to instrument, collect, and export telemetry data from your software. You can use it to understand what your software is doing, how it's performing, and where time is being spent during execution. You can see this trace here. We can see that over the course of a request, 21 microseconds were spent in the router of 2 milliseconds. Like, that's pretty quick, and most of our time was taken by the rate limiting plugin. I'll show you how to actually configure this in just a moment. Understanding how Kong Gateway is performing is a key part of any deployment, and we're excited to announce extensive tracing support in both Kong Open Source and Enterprise. This is the first time this is available in Kong Open Source. Gone are the days when a customer complains that Gateway is too slow and they don't know why. Going forwards, they can enable OpenTelemetry and see that detailed breakdown of where time is being spent by Kong Gateway to help increase performance and throughput. There are 2 ways to get started. You can use the out-of-the-box OpenTelemetry plugin to send OTel spans directly to any compliant backend or to an OpenTelemetry collector. I've been testing Kong with Honeycomb. That's what you'll see later, and it just works. You can also integrate with third-party platforms, such as Honeycomb or Datadog, using the plugin development kit. Using the OpenTelemetry collector, and get all of your traces in there. So I've used OTel collector with Datadog, and it looks great as well. We also provide a plugin development kit to enable our customers to instrument their own custom plugins and understand where time is being taken in those custom plugins. There are a few non-limitations today. Unfortunately, that PDK is only available for Lua plugins, and it does not support all observability providers' functionality. It only supports tracing. You'll need additional plugins, such as the Datadog plugin, for advanced use cases such as metrics and logging. Right, back to the live demo. So what I'm going to do, I've created just an OpenTelemetry demo service and a route. And I've just configured the OpenTelemetry plugin. So all you need to do is say use OpenTelemetry, give it an endpoint and any authentication. Don't worry, I will be rotating that key as soon as this call is done. And now if we start making requests, that is the wrong command. So it's just /root. So localhost 8000. Let's see. And I'll just make a couple of requests. And what Kong Gateway is doing now is generating all those traces, all those spans in the background. And if I go back to my browser and go to Honeycomb, fingers crossed, they are showing up. So you can see that get OT hello. Let's make that a bit bigger. I can go into the span. You can see that Con Gateway took 425 milliseconds. Again, the router was super fast, and that most of our latency was added by the upstream itself. This is a great way to say, like, Con Gateway is taking too long. It's usually not. It's usually the upstream, but now we can prove it using OpenTelemetry. All right, we're flying through this. Like, this is just how easy it is to get started with these new plugins. Like, create a service, like you know how to create a route, and then just enable the plugin. Kong Manager. For those of you that aren't familiar, Kong Manager is a UI that we provide to help customers configure and monitor their Kong deployment. And Kong Manager 3.0 ships with a new design and improved user experience, including more tooltips. We've revamped Kong Manager in 3.0, making core gateway entities such as service, route, consumer, and plugin configuration more intuitive. Understanding how an entity is configured is now presented front and center, rather than being hidden behind that view config button. So the left was Kong Manager on Gateway 2.8, on the right is 3.0. We've also updated empty states to make it easier to get started. We've added tooltips to explain configuration options, and it's now harder to accidentally delete a service or a plugin. Screenshots aren't the same. I have a running Kong Manager instance. We'll just go and click around it so you can see what it looks like. So one of the key things to look at here is these Christmas lights. It makes it very easy to see at a glance how your services are performing. See here that most of my requests are 2xx, which means they're okay. 2.41% average error rate, that's okay-ish as well. I can see when my license expires. I'm using a development license, so I've got about 2,600 days left. Yours will tell you how long you have left on your license. And then we can click into a workspace and then choose a service. Let's choose service staging. And you can see at a glance how this service is configured, what the configuration is, what protocols it listens on, what ports. We can do this for routes. We've had a lot more colors. You can see this responds to get, post, delete, and options, which hosts and which paths it responds on. One of my favorite things, which I didn't know until Kong Summit when Guanlan presented this section, was that you can actually click these. I can enable and disable plugins just by clicking this, this little enable button. If we go ahead and create a new route, previously you had to paste UUIDs into this service, but now it's just autocomplete. It filters down as you type. It makes it really easy to configure your services and routes. That is a super quick tour of Kong Manager. I highly recommend clicking around in your own environment and just seeing what kind of information you can get out of your own services and routes. So as I said, I didn't know that you could click the enabled and disabled buttons. Like, that was one of our best kept secrets until G shared it with us all at Summit. And speaking of secrets, I would like to introduce you to the final flagship feature that we're talking about today, which is secrets management. Now, secrets management allows you to store sensitive information securely in external vaults. You can use environment variables for open source, or you can use AWS Secrets Manager, Google Cloud Secrets Manager, and HashiCorp Vault if you have an enterprise license. And then you can have Kong access those values at runtime. A secret is a piece of sensitive information that Gateway requires to run. It could be your database password. It could be a secret key for a plugin. It could be an SSL certificate. No matter what it is, you probably don't want it being publicly accessible to anyone that has access to your config. By storing sensitive values as secrets, you ensure that they're not visible in plain text through the platform, either in cong.conf, in your declarative config files, in your logs, or even in the Kong Manager UI. Like today, if you've got a secret value in your proxy cache plugin to authenticate with Redis, anyone can go in, click edit plugin and see that secret. Using secrets management, that goes away. All they see is the vault reference. In addition, using vault secrets allows you to have per environment values for development, staging, and production, while still using the exact same declarative configuration file, because each environment can point to its own vault that uses the same path, but different values. We're shipping with 3 enterprise vaults: AWS, HashiCorp Vault, and GCP, and an open source environment variable driver. You can reference secrets using an intuitive format. It looks like this on screen on point 2. So Vault is the protocol, and then the driver, so it could be AWS or HCV or GCP, and then the path to the secret. And Kong will automatically resolve those secrets at runtime, ensuring that they're not available for people to read. And once again, this works a lot better when you can actually see it work. So let's go on to the demo. So I just need to export my Vault address. I have Vault running on localhost port 8200. Nope. And I didn't mean to put that at the beginning. So I can do vault get kv. Here we are. This is testing my memory. Vault kv get mount secret Redis. No, there is no secret there. So let's go ahead and set a secret. And it's put, not set. See, this is where my memory is failing me. There we are. So now if we get that secret, we can see that in /redis/password, we have the value demo. If we start a Redis server, we're doing require pass demo, and just to prove to you it works, I can't access it without authentication. But now it will show me that we have no keys. So at this point, I have my Redis server running. I have a vault with the secret key. The last thing to do is actually create a service and a plugin config that uses that. So once again, I'm just going to create a service, create a root, starts with /sm. So localhost 8000. And actually, let's show the headers as well. Oh. Start that again. Curl -i localhost 8000 secrets management. Hello, there we are. And there's nothing in these headers right now about caching. So let's go ahead and add the proxy caching plugin. Here, I'm adding it. It will cache any GET requests. It's using Redis to cache. I'm running Kong Gateway within Docker, but running Redis on my local machine. So I'm saying use my Docker host. And here's the key part. I'm saying look in HashiCorp Vault in the Redis secret in the password path. Redis secret, password path. So if I go back and make that request again, this time we should see X cache key. We can see that the cache status was miss. But if I go back to my Redis CLI and list out the keys, we actually see that item just there. And if I make my request again, it comes back super fast because proxy caching is enabled and the cache was hit. So this is an example of how you can use secrets management to secure your Redis credentials. But like I said, you can use it in anything in Kong.conf. Any plugin marked referenceable. If you check out the Kong plugin docs, if you see the word referenceable, it means that you can use a vault reference in there. All right, that's all of the demos. We'll just do a quick deep dive through the architecture, and then I will come on to the questions that you've all been asking. Great to see so many questions. This is beauty on the inside stuff. This isn't necessarily something you would see day to day, but it's super important for keeping Kong Gateway performant and stable. The first thing we shipped is a new timer library. Using a timer is unavoidable. We have to do a job every once in a while or after a delay. The HTTP log plugin, for example, flushes the access log on each request. And what used to happen is OpenResty created a fake request and a call routine. And each of those fake requests takes up a certain amount of memory and it occupies a connection just like a normal request. OpenResty uses a linked list to manage all those call routines. And as the number of call routines increases, it becomes more expensive to read and write the linked table because it's always in complexity. Once the time task expires, we pick a timer from the timer pool to run the task. And when the timer pool is empty, we just let that task queue expire. And as a result, even if we keep starting the timer, the number of fake requests and call routines in the systems will be relatively stable, which means that we don't receive a big performance impact. We tested on a modern server without any load for each timer. If we did this in a real world deployment with more compute heavy jobs, this becomes less pronounced. But you can see the number of requests per second with the original timer decreases logarithmically. It drops very fast. But with the new timer library, it's a linear decrease. And the number of requests per second stays quite high. This is probably a good time to talk about new events library, as the timer library is heavily centered around events. In the old model, a worker would write one or more event items into a shared dict, into shared memory, and then post a message to notify all of the other workers using the event system. Then every worker starts to poll events to try and get message from the shared memory at the same time. One of the workers will receive, say, a route to change request. It will go to all of the worker nodes to make sure that the change request is propagated to all of them. And the way it works is it uses the shared dictionary of events. So with 32 workers and only 13 items in the shared dict, when a worker is reading from the shared dict, it locks that. And what happens is everything becomes locked and performance drops. Using the REST worker events, we use a timer and sleep to actively pull events from the shared dict. Now, we've rebuilt this in Kong Gateway 3.0. Instead of having that sleep and pull, where everything's trying to access the same shared dictionary with lockings, we've introduced a new pub/sub system. We have an event broker, which is a service running one and only one Nginx worker. and then an event publisher and an event subscriber that can run in any Nginx worker. Lua REST events uses a Unix domain socket for communication. So it posts messages across that domain socket, and all of the other workers are listening on an Nginx thread for messages to respond to. So instead of constantly polling, they're just waiting for messages to be pushed to them. There's a big impact for this. You see in the first case, Lua REST events and Lua REST worker events are about the same. REST events being the old implementation and worker events being the new one. But in the second case, where instead of running 1,000 requests every half a second, where we run 10,000 requests every 0.1 seconds, worker events is significantly better. It's about 40% more performant than the old locking messaging system. This is the final beauty on the inside change, which is LMDB, which stands for Lightning Memory Mapped Database Manager. This is a transactional embedded key value store. And our previous way of using storage was that shared dictionary, which is a global blocking event. That means there can only be one Nginx worker reading from a shared dict zone at once. I would tell those numbers 1 to 13, one worker per slot. And this shows up as less than ideal scalability issues as the number of Kong workers increases and the workers are waiting their turn to read. With LMDB, the database structure is multi-versioned, so readers can run with no locks. Writers cannot block readers, and readers don't block writers. It supports multi-process concurrent writes and reads, so you can submit all your transactions safely. And it supports persistent and is fully ACID compliant. That means that when we're writing data, you know it's not going to be lost. LMDB allows Kong to run faster with less memory usage. It lets it handle very large configs with ease, but it will help us bring even more advanced features. We're just getting started. It'll allow us to build in things like incremental sync for hybrid mode through leveraging LMDB's transactional support. It's the foundation that's going to support our vision of making hybrid mode the preferred method for Kong deployments. When you push config, the request per second serving from a data plane is notably better with LMDB. So this goes back to when we're doing things like a routing update. We can see that the number of requests per second stays fairly consistent with LMDB and is about 100,000 requests per second faster than the shared dict approach. That was all the beauty on the inside changes. I showed this slide at the beginning of the session, and we ran through these 4 features. Which means we didn't even touch upon these ones. And these are 5 flagship features too. Like this slide, this 9 are just the highest impact, the highest visibility things. And there are dozens of smaller features that we ship too. If you want to learn more, head over to docs.conkhq.com/gateway and take a look at the release notes. Thank you for your attention so far. I think it's time to turn it over for questions.
Thank you so much, Michael. We have a few questions in the Q&A chat.
Cool. I will take them in order in Q&A. Hi, Mohan. What is Coco? Great question. So Coco is the next generation Kong control plane. The idea behind it being that Nginx, OpenResty are wonderful for proxying traffic, but it's not really ideal for building a control plane for handling all of that, the Kong gateway configuration that you need to do. So Coco is the next generation control plane for deploying Kong in hybrid mode. If you want to give it a test drive today, you can head over to Kong Incubator. Let me pull that up right now and share my screen again, because this is something that you should all see. So this is incubator.conghq.com. You can go down and see Coco. It adds a little bit of background. It's the next generation control plane. Gives you a comparison with the existing control plane and gives you a quick start. Do not run this in production today. We want you to keep the tires, try it out. This is a technical preview. We make no guarantees. I will show that this is what's powering Kong Connect, our cloud offering. So it is fairly battle tested at this point. Like, Kong is using this internally. I think the third phrase is drinking our own champagne rather than dog fooding our own products. But yeah, that's what Coco is. Next generation control plane being used by Kong Connect, and you can give it a go by heading over to incubator.conghq.com. Okay, next up, Jay, can you tell me more about the Kong.log.serializer changes? Honestly, I cannot, not without a little bit more investigation. If you head over to the Kong Gateway GitHub repo and raise an issue, tag me, I'm at mheap. We can take a look together. Mert. Sometimes I have pain deciding when I need to use Kong Gateway or Service Mesh, Kuma. Can we say that Kong Gateway 3 has moved me away from service meshes a little more? It really depends on your use case. If you're using the service mesh for observability and the OpenTelemetry supporting Kong Gateway is enough, then perhaps. If you're looking for secured intra-service communication, east-to-west traffic through MTLS, service mesh is probably still a good choice. It really depends what you're trying to achieve. Mert again, on the topic of OpenTelemetry, does it cause a slight delay between client requests and the services? No more than any other plugin. We're talking microseconds. This is because the spans are recorded internally and then flushed to the upstream asynchronously. So we don't have to wait for the upstream service to respond. Sorry, the upstream OpenTelemetry service to respond before sending back the response from your actual upstream. Is Kong Manager available for the open source version? It is not. However, you can get it for free. So we offer two distributions, Kong Open Source and Kong Enterprise. Kong Enterprise is available free of charge, including Kong Manager. The only difference is that the source is not available, but you can run it for free forever. So there's no commitment. All you have to do is install the Kong Enterprise package and you will get Kong Manager for free. Can Kong support both 3.0 and 2.0 routes at the same time? Old routes in the 2.0 router engine and new routes by 3.0. It cannot, Dennis. You have to make a choice when you start Kong Gateway by setting that router flavor. Your options are traditional, which uses the 2.0 router, traditional compatible, which uses the 2.0 format with the 3.0 router for the increased router rebuild time, or you can set router flavor to expressions and use the new routing DSL, but it is unfortunately an all or nothing decision. And if a plugin interacts with Postgres, then does OpenTelemetry plugin show the DB interaction time? Yes, it does. It will show you the DNS time to look it up and how much time the plugin took. If you use the Lua PDK and wrap your database queries as separate spans, they will show up in OpenTelemetry as well. Sachin, are there any new plugins that support integration with Splunk? Not Splunk specifically, but I believe you can send logs to Splunk using our existing plugins, either the file log plugin with the Splunk forwarder, or I think the HTTP log plugin will also work for Splunk, but I would have to double check that one. Creating custom plugins and deploying it in each DP node is a manual process. Unlike our conversion, we'll be able to create custom plugins using Kong Manager / the admin API. If not, is this in scope for upcoming releases? You are right, it is currently a manual process. Is it in scope for upcoming releases? I know that the team has been discussing streaming plugins from the CP to the DP, but no commitments on that whatsoever. It's more of an exploration phase today. But is it possible? And then we will see if it's possible and decide if we're going to ship it and when we're going to ship it. In case of using Kong as an ingress controller for Kubernetes, is it possible to use the DSL-based routing? I believe so, because the ingress controller wraps Kong gateway. You would need to make sure that your CP and DP pods are started with the Kong router flavor environment variable set to expressions, but otherwise you should be able to use DSL-based routing. Purushottam, will we have a signal log plugin for Kong 3? Honestly, I don't know. Feel free to raise an issue on GitHub or talk to your account manager if you have one. Saravanan, is runtime groups feature only available in SaaS? Yes, today it is only available in Kong Connect. So for those that aren't familiar, runtime groups is a feature that gives you virtual control planes. You can have a single pane of glass to view all of your services, all of your routes, all of your plugins, but isolate config completely. So each runtime group gets its own services, routes, consumers, plugins, everything. It works great in a federated model where teams own their own configuration and use declarative config and deck to push things up. But yes, unfortunately, it is only available in SaaS today. Where can we find the principal differences between 2.0 and 3.0? Do we have one link? Yes, we do. That will be docs.conkhq.com/gateway/changelog. Everything that changed is on that page. Mert, I was wondering if you can explain dynamic plugin ordering a bit. Sure. So dynamic plugin ordering is a new 3.0 feature. And previously, all Kong plugins had hard-coded priorities. So sorry, I'm just going to need a cough. All the plugins had hard-coded priorities. So the authentication plugin would always run before rate limiting, as an example. Now, this is great because you might want to rate limit based on the consumer. But what happens if someone is trying to brute force your authentication? You might want to run rate limiting first based on IP. So what plugin ordering does is let you specify a plugin name. So config.before, where you could say, run the rate limiting plugin before you run authentication. You won't be able to rate limit based on consumer anymore, but you will be able to rate limit based on IP and protect your database from all that traffic whilst people are trying to brute force your authentication methods. There are examples in the Kong docs. If you go to docs.conkhq.com, click on Gateway, Kong Enterprise, Dynamic Plugin Ordering, you'll see a concrete example there of how to use it. Or you can head to conchq.com/blog and look for a blog post on dynamic plugin ordering from Victor, one of our developer advocates, that walks you through exactly that use case where you have to put rate limiting before authentication. Jay, do we suggest to upgrade from 2.03 to 3 directly, or go from 2.0.3 to 2.8.1 to 3.0? The answer is neither. We're about to release 2.8.2, and Con Gateway 2.8.2 enables blue-green deployments for those migrating to Con Gateway 3.0. So my recommendation is to go from 2.0.3 to 2.8.2 when it's released. Should be in the next week or so, and then to Con Gateway 3.0. Final question. Where can I read more about WebSocket support for Kong? If you head over to docs.conchq.com, click on Gateway, Kong Enterprise, and then WebSockets, you can learn more there. Alternatively, head to the plugin hub, and there are 2 WebSocket plugins there. Request validator and frame size limit. So the request limiter runs on every WebSocket frame. I can't remember which one I said. Let's do frame size limit first. It runs on every WebSocket frame, and if the frame is too big, it will refuse to send that frame to your upstream or to your client. It works in both directions. You can configure the size differently, whether it's going upstream to client or client to upstream, so you can protect your consumers from oversized frames. In addition, you can use the WebSocket validation plugin. It will run on every frame, and if the message does not meet the JSON schema that you provided, the frame will be rejected. Again, works in both directions, client to server and server to client. We showed Mert, we showed almost 10 new features. Are these running as components? So I can remove the one that I don't need from Con Gateway 3.0, or I can get one and use it on Con Gateway 2. They are not. Everything that I showed today requires Con Gateway 3.0. Some of them are running as plugins, for example, OpenTelemetry. You could remove that from your build if you wanted to build custom images, but it doesn't make much sense to, because unless you enable OpenTelemetry, there is zero performance impact. But yeah, to use anything that I've shown today, you have to be running Con Gateway 3.0. That is all the questions.
And I see one more in the chat from Manzat. He's asking about Cassandra.
I see, yep. Thank you for your question, Manzat. Cassandra is deprecated in Con Gateway 3.0 and will be removed in Con Gateway 4.0. The alternative is to switch to Postgres. Most of our customers are using Postgres for very high scale deployments, and you can set it up for, with active-active deployments so that you have a highly available cluster. Yeah, if you search for HA Postgres active-active, that will give you all the information you need.
All right. Thank you so much, Michael. I think that were, oh, wait, one more. Oh, no, that's Apple explaining. I think that's all the questions. Let's give it a few more seconds. Any last ones?
Excellent. Well, thank you for your attention, everyone. I've enjoyed it. Thank you for all the questions. There were lots of great questions in there. Dalia, back to you.
Yeah. Thank you so much, Michael, for the great presentations and for answering so many questions. Thanks, everyone, for attending. The recording will be available tomorrow on our YouTube channel if you want to check it out again. And yeah, thank you again. We hope to see you at our next event. Have a good evening, good day. Bye-bye.